Howdy, I'm Abraham, and this is Kinetic. So, what Kinetic is an application that can take you from just a basic data set to a full-scale machine learning solution. What we do is when you're actually working with our application, you can see we sort of start off with Start Engine. And what this does is you first make an account. Now, in our case, we already have an account made, and we'll just sign in real quick. Once we're signed in, what you essentially want to do is create a workflow. And sort of the example I want to give in our use case is, let's say you were a scientist and you were researching breast cancer and you had a lot of data on breast cancer and you were just wondering, hey, I have all this data. Is there something I can do to sort of detect breast cancer, to sort of build a solution for this problem that I have, right? And obviously, as a doctor, you may not know all the ins and out about machine learning, and you may not know how to tune all those parameters, or even for high performance computing, right? And that's where we come in sort of as an application to simplify that process. In our case, all you have to do is take the data that you have, in our case, your cancer data. It can be a CSV and other formats like zips. And this is all then sort of fed into Nematron. And what Nematron does is it will analyze this data alongside a message that you can send it, and let me upload the file also. Build model. Inside this message, you can just essentially give it a general big idea of what you want to do with the data, or you can also get really specific in it. Now, in our case, we're gonna sort of try to keep it broad and just give it the data and give it the what we want it to do with the data, right? And once the data has been uploaded and all is good, we can generate the models. Now, the reason it says generate models is what our product does is generate a wide variety of models depending on the different kinds of problems. Depending on the structure of the data, it may generate a KNN model, a logistic regression, a deep neural net, and other kinds of models. Now, once it's done generating these models, we can launch training. Now, this whole training process, how it works is basically what Dematron does is once we feed it a sample of our CSV alongside the problem we want it to solve, it returns back to us with some Python programs, which are then run in our Vultr compute server, right? And after it's running the Vultr compute server, all the outputs are stored into our Vultr bucket, which can then be displayed here on our application. Now here you can see every so often we do have some models that do fail, which is completely fine since we built a feature just to rerun them. But you can see some of them do work here, for example, the random forestry. And for the ones that do work, you can see sort of some evaluation metrics like train accuracy and train loss. Now, something I do want to mention is you'll probably notice that the features right now for evaluation are a little baseline. However, this was done in order to sort of simplify our whole program because when having different models, we really needed a baseline way to generate consistent code. And that's why we sort of forced it into this sort of specific metrics that we wanted to generate, right? Now, something that this does allow us to do is compare the models because they all do have the same metrics, it'll allow us to sort of compare them. Now, in this case, because only the random forest model ran correctly, it's not working too great, obviously, in this case. But an additional feature we do have is this AI explanation feature, where essentially, if you have any more questions, like other than just these basic sort of features that we give you, you can ask it, hey, how can I better evaluate? Right on the, how can I better evaluate the random forest model? Now, once you send this over, what it'll do, it'll send this to Nematron and it'll just give you a better explanation for how you can do these different things and just in general give you a better understanding for the model. Now, that is all for now, and I just want to say thank you so much for listening and gig 'em.